Well, thank you all for joining us today. My name is Yves Laurent. I'm responsible for technology partnerships here at Couchbase. And for the session today, I will be joined by Saurabh Shanbhag, who is the Partner Solutions Architect at AWS, and with who we have been working with for many years now at Couchbase. I'm also joined by Kiran Mati, who's the lead product manager for AI at Couchbase. And in the session today, we will cover why you should make use of Couchbase vector search with Amazon Bedrock. So really excited about this session today. Going to the agenda, we will start off with a brief introduction on the partnership between Couchbase and AWS, which has been in place for many years now. Then I'll hand it over to Kiran, who's going to talk a little bit more about the voice of the customer, what we're hearing from our customers when it comes down to their projects and plans around generative AI applications and how they're thinking about addressing their business requirements using our technology. Then we'll cover Couchbase Capella and all of the capability that it offers to help customers to build those generative AI applications. Then Saurabh will take over and introduce Amazon Bedrock, the capabilities that it provides and how it can work together with the Couchbase database platform. And then we'll close it off with a demo to show all of this in action. So let me briefly touch on the partnership that Couchbase has in place with AWS. Our goal here at Couchbase is really to provide our customers with leading industry solutions using the Couchbase database platform together with AWS services. And so for this, we implemented a multi-year strategic collaboration that really covers a build phase and an accelerate phase, how we take our joint solution to our customers. On the build phase, we make use of a wide range of AWS services to provide our customers really with an enterprise class database platform to build those mission critical applications. On the accelerate phase, we work closely with AWS in driving a joint go-to-market. We are looking at achieving a number of certifications and competencies. You see there that Couchbase is a data and analytics competency partner. We participate in programs like the Workload Migration Program to help customers to move towards a modern platform using Couchbase together with AWS. We facilitate proof of concepts with our customers together with AWS, and we facilitate the transactions on the marketplace of AWS and support private offers. With that being said, let me hand it over now to Kiran, who can talk a little bit more about our customer requirements when it comes down to generative AI applications. Over to you, Kiran.
All right. Hello, everyone. This is Kiran Madi. I'm the lead PM for AI/ML here at Couchbase. So I'm going to start off with the voice of the user. That is your voice, actually. And then I'm going to build on it, diving deeper into the Capella capabilities. And then I'll hand it off to Saurabh to talk about the integration, starting with the demo. Okay, I'm going to move on to the next slide now. All right. So several customers that are listed here and many others use Couchbase today as a profile and a catalog store. By profile, I mean those are the details about you, such as your preferences, your location, and so on and so forth. The data that is used to basically personalize your experience with the GenAI applications. And in addition to that, it is also used as a catalog store where our customers store product catalogs that you can quickly search via your mobile or desktop applications. And the reason these customers flock to Couchbase is because of its performance. As you can see here, Revolut, one of our fintech customers, they have a platform. It's an award-winning platform which can detect fraudulent transactions under 50 milliseconds, right? And again, this is not an exhaustive list. We have many other customers that use it in very innovative ways. Let me move on to the next slide. So that was our current state. And this is what our customers have told us where they see Couchbase as a good fit along with Bedrock to help them realize their use cases. Starting with the fintech customer here, the use case here is to upgrade an existing chatbot application that does not use RAG. So they want to use RAG with leading LLMs, which Bedrock offers a wide range of LLMs that sort of will deep dive into in a little bit. And in addition to that, they also want to moderate the responses of their chatbot. And for that, they need something called as AI guardrails that sort of will hit on in his talk, all right? And the other use cases that we come across are mostly around customer support. This is about making customer support more efficient by summarizing your past tickets, call logs, so that every time you call customer support, you don't have to repeat your story, which can be very annoying, as you know. And it uses RAG to make that happen. And Couchbase helps accelerate the knowledge discovery, actually, and it's an important part of that RAG pipeline. And another popular use case that we usually come across is around product search and recommendations. And this is mostly in the retail space, but it applies to other verticals as well. So you must have heard of something called as a stock out. A stock out event usually happens when you look for a product and it is out of stock, basically. It costs retailers millions of dollars per year and creates a very bad shopping experience. So the basic idea here is to detect a stock out event. And when that happens, you want to run similarity search or semantic search and recommend similar products so that you can convert an awkward moment like a stock out into a sales opportunity. Okay. And there's another trend that we are seeing where shoppers use product descriptions or images basically to look for products. And we want to support that. And you can personalize that experience using the user profile that I mentioned to you earlier, using Couchbase as a profile store. And lastly, for retailers, omnichannel experience is very important. They want to create a unified experience across mobile and desktop. And the reason we shine in that space is because we have a mobile offering that I'll talk about in a little bit. And I've added a link to the resource section as well. All right. And finally, as you know, agentic workflows are all the rage today. And the idea there is to ask complex questions to your AI agent, right? Something like, how does the financials of this store, the keyword here is this, compare with the least profitable or the most profitable store. And to resolve this reference, you need a cache such as Couchbase. And I'll talk about the conversation cache in a little bit. All right. Moving on to the next slide. Okay. So the remainder of this talk will be focused on how Couchbase and AWS Bedrock enable users like you to realize the use cases that I mentioned earlier. So you will basically enjoy the best of both worlds here, and Saurabh will showcase that via a demo. All right. So we have worked backwards from what our developer users basically need. And their main ask here was for a single data platform that encompasses an LLM cache, vector store, and the profile and catalog store that I mentioned to you earlier, including a transactional DB. So an LLM cache is basically used to reduce the number of calls to an LLM, right? And the advantage of that is that speeds up the response of your chatbot And at the same time, it reduces costs as well, because running an LLM adds to the latency and also costs, as you know. Okay, so there are three flavors of an LLM cache that we support, starting with the standard cache. Standard cache is basically a KV cache that looks at your prompt in its entirety, and then based on a cache hit, will fetch the response from the cache. Okay. Semantic cache, on the other hand, looks at the semantics of your prompt, and based on a cache hit, will return a cached value. Semantic caches usually have higher cache hit rates as compared to a standard cache. And the reason for that, as I mentioned to you earlier, is because of the semantics of the query. And lastly, a conversation cache allows you to refer to past conversations, like the one that I shared with you earlier around this, right? The LLM wouldn't know what this is. So we can use a semantic cache to provide that context, what this means, or other references. We launched our vector store earlier this year, and it was well received by the market, mainly because we have a feature called hybrid search that I'll talk about in greater detail in a bit, that lets you combine traditional search with vector search, actually, to achieve very granular search results. And I already talked about the profile and the catalog store. So the key takeaway here is that there is a single data platform that offers you all of these, rather than you deploying multiple databases, which can be an operational nightmare. And in addition to that, we are completely JSON compliant. And we have something called as SQL++, which is SQL queries run against JSON, optimized for JSON. You can also set up your LLMs for JSON mode and store the responses in Capella. And just like any other developer wants, is a broad ecosystem so that they can leverage the innovations that the open source and the closed source companies products bring to the table. All right. We have roughly 20 plus integrations at the moment that encompasses AI platforms like watsonx, Bedrock, Vertex AI, and so on and so forth. In addition to that, we also have integrations with leading AI app platforms such as Llama Index and LangChain, and also several AI ops tools. And our customers flock to us for the reason that we have a mobile offering as well, which allows them to provide a complete end-to-end solution from the edge to the cloud. This talk is not about mobile and edge AI, but we'll cover this in a separate webinar. And I also have added a few links in the references section. All right, moving on. So what makes us different is we are a multi-model database where within the same SQL++ query, you can access key value data model of textual data, geospatial, time series, and so on and so forth. All right. And in addition to that, as we mentioned earlier, we are a DBaaS. Capella is a DBaaS, a database as a service. So it offers several capabilities that removes the operational load from your operations, basically. And okay. Now, as I mentioned to you, one of our differentiators is the Capella hybrid search. Hybrid search is basically blending. Sorry, I missed a slide here. My bad. All right. Capella vector search is something, as I mentioned to you earlier, we had launched this earlier this year. There are two parts to a vector search, actually. One is the indexing aspect of it. Indexing covers real-time indexing. So we index the data as soon as the system sees it. Okay. We support up to 4K dimensions. So you need to exercise some caution here because there are cost implications when you go for higher dimensionality. And so it's a trade-off between accuracy and cost. We support L2 norm and dot product distances and cosine as well, which is basically normalized dot product. And in addition to that, we offer two more knobs called recall and latency. We use fast indexing. As you know, it's a leading indexing technology under the covers. Fast exposes a lot of knobs, which can be very confusing to developers. So we have abstracted all that and reduced that to just two knobs here, recall and latency. Okay. And setting up indexes is fairly simple. You can either use our UI, where you get a guided experience for creating an index, use REST API or SQL++. So once your index is ready, you can bring to bear different query formats that we support, starting with a single vector. You can create a single vector and query it from within a SQL++ statement, or you can create multiple vectors, and we support both OR and for those vector searches. And in addition to that, this is our differentiator, as I mentioned to you, hybrid search, where you can bring to bear full text search and combine that with vector search for very granular searches. And I'll give you an example in the next slide. Additionally, you can use geospatial and vector search as well. All right, so let's deep dive into hybrid search. So as I mentioned to you, hybrid search basically balances exact keyword matches with the semantic relevance of a query. And the way we do that is we take the user's query and convert it into a sparse vectors using TF, IDF, the traditional methods of indexing, and inverted indexes into full text search indexes. And on the vector search side, we use embedding models such as OpenAI, the ones that are offered by Bedrock, to create dense vectors and write them to the vector index. And then we allow you to basically use a single SQL++ query where you can query both the sparse vectors as well as the dense vectors and generate a list. And we also support something called as boosting, where you can pick certain fields, you can boost certain fields so that the re-ranking is based on that particular field. And you don't have to use a re-ranking model or anything here. We take care of it behind the scenes for you. And the advantage of this approach is that it allows you to be very selective with your searches, be very do very granular searches, basically. Okay, and that is hybrid search. As I mentioned to you, that's one of our differentiators, and Saurabh will walk you through it in the demo as well. Finally, I covered all of these earlier. So the key takeaway here is that you can use any of these caches with a few lines of code in LangChain, as you can see here. And finally, to show you how all of these come together, here's the reference architecture. Consists of two parts, as I mentioned to you earlier. For our vector search, there is an indexing aspect, and then there is the querying aspect, which is a part of the application, the chatbot application. So starting with the indexing path, you have a corpus of data, unstructured data, that spans PDF files, PPTs, emails, and so on and so forth. So inside of your LangChain application, you can extract the data. So LangChain has the capabilities for that. And we have several sample applications also, and the one that Saurabh can show you in a little bit, which allows you to extract the data, cleanse it, chunk it, and then index it to our vector DB. So while you do that, you have to implement this embedding logic, which calls an embedding model inside of Bedrock, and basically vectorizes or converts your text into vectors. And that, once the vectors are created, you have to write it to our index, which, as I mentioned to you earlier, is the FIAS index. Okay, so once the index is ready, you can develop your chatbot application that uses it to retrieve context for your RAG. Okay, I'll walk you through it now. So the user, the end user, could be a financial analyst or whoever, asks a question. The chatbot application basically does a vector search against the index that they just created. Okay, and what you get is basically the context, which drives the RAG, retrieval augmented generation. Okay, and you get the top K documents, which are your prompt is augmented with the context actually, and sent to the LLM. So what you have is now the prompt and the context, and it is sent to the LLM, and the response of the LLM is a grounded response because you had sent it the context associated with that question. Okay, and that is what we send back to the user as an answer. Right, and again, this reference architecture is still missing certain components to make it enterprise ready. And we'll talk about that in a little bit, where you can bring to bear Bedrock guardrails for content moderation. You can do content filtering that's available in Bedrock. And additionally, you can use the LLM cache that I talked about earlier to speed up the responses and reduce your costs. And finally, if you're concerned about privacy, you can also set up a private link between Bedrock and your VPC, or between Capella and your VPC. Okay, with that, I'll turn it over to Saurabh.
Thanks, Kiran. It was really great to dive deep into Couchbase offering and why it's so relevant because of so many features it which provides to customers to get started with on the JSON side. I want to go over the Amazon Bedrock side of the picture now, and then we will look into how Amazon Bedrock integrates with the Couchbase vector search in the demo later on. So let's go over around what is Amazon Bedrock and how it can be very helpful in your journey towards getting generative AI or a RAG application going in your organization. So if we go on to the core thing is we have, like on the AWS side, we have listened to our customers and they need something to get started with easily, right? Like they want to build these generative AI applications, and we wanted to make that journey easy. And the easiest way for our customers to build their applications and scale their generative AI applications, that's the foundational tool what Amazon Bedrock provides. Again, because it's a very evolving field right now, there are still more models being created, better models being created, and customers want that choice of which model is more relevant. There are various applications around models, but the key things when model selection comes into play is the latency, right? Like what's the latency I'm getting? There are some cost implications as well. But at the same time, customers also look for if my current application needs this complex of a model to get around, right? So, for example, I would just say if you are working around customer support and you just want to know if you want to alert or create a escalation so that some additional person should look into a support ticket immediately, that can be created by a model, but probably you don't need a very complex model for it. At the same time, there are certain models where, for example, in the chatbot, you need a model which can understand complex language as well as provide good latency as well, right? So there are different aspects on model choice which customers have to take into consideration. So Amazon Bedrock provides that choice to customers. We'll also look into something it provides around customization. So model customization is something which a few customers need because if you are in a vertical specific industry and the model was trained on general English language, it might not be able to understand all the verbiage or the kind of contextual information of your vertical, specific codes you use, specific formats you use, and the output of the generative AI model will not be in a similar format. For that, you might need to do model customization, need to do additional training for that model. The third picture I want to talk about is retrieval augmented generation. Retrieval augmented generation is very, very much relevant for a lot of customers because these LLM models are trained on very wide, publicly or available data sets. They are not trained on your private data set. Like, for example, you have private data. That data is very valuable, but now you can extract value out of it using these generative AI models. With the RAG, retrieval augmented generation, you can get the relevant document chunks out of your data set and then send them to the large language model. Now it can understand the context and get you the right response. This, we see that customers see hallucinations reduced tremendously based on this. At the same time, they get context from which is proprietary or to their organization. They can get very relevant response from the LLM model by sharing that internal corpus with that LLM. Next step is on the agent side. This is going to be an additional step. I see a lot of things happening here because agents can actually go out and do some actions as well. It can set it up in such a way that it can call an API, do an action, do automation, rather than just giving a response back, right? But at the same time, I understand everybody is concerned about, how secure we are. Is there proper data governance or privacy? So Amazon Bedrock understands this. We have worked with a lot of enterprises, and I will also go over areas around security, privacy, and data governance in the slides following. Yeah. So the core thing is, the key takeaway here for Amazon Bedrock is it simplifies, right? It simplifies your whole journey towards creating a generative AI application because first you get a choice. You get a choice of various LLMs. You can choose which are more relevant to you based on latency, complexity, and cost. The second thing is, even though you have these LLMs now, they might not be, the right fit as the base model. You might need to do some customizations. If you are in a vertical specific industry where there's certain language which the model is not accustomed to, you have to do a little bit of training there, right? Third thing is around integration. Bedrock is integrated with a lot of partner services as well as AWS services, and that will give you more tools to integrate and create applications faster. And the last thing around security and governance, I want to again focus that the data which let's say if you bring data to Amazon Bedrock, that data is not shared to train a model. If you are doing customization training like fine tuning, that those model weights are only yours. They're not shared with any customer or even the LLM provider. So you get complete security when it comes to data and privacy there. At the same time, we have various networking construct. I know Kiran went over something around private link. So we have a lot of tools there which help you to kind of know that your data is secure. It's not going over public internet, and you have the right governance placed on it. We'll go on to see that when I was talking about the choice, so this is the wide array of Amazon as well as private or partner large language models which we support. So AI21 Labs, Amazon, Anthropic, Cohere, Meta, Stability AI, Mistral, all these language providers have multiple models available on Amazon Bedrock. At the same time, we keep working with these partners to onboard new models. The latest model from Anthropic, for example, Claude 3.5, which has great capabilities when it comes to even generate code or those applications. So based on your requirement, you can select specific models out of these. At the same time, you can be rest assured that you're the API or the SDKs which you're using with Amazon Bedrock can be used across these models. And whenever a new model is launched, you don't have to switch and move on to a new provider. It can be captured through the Amazon Bedrock itself, right? So those are the key advantages. You get that choice. You are able to evaluate different models right in the same platform, right? Going on, I did mention that we have areas around customization. So one of the key thing is AWS presently provides fine tuning even on the Anthropic Claude 3 models. We are the only provider which lets you to customize fine tune models from Claude 3 models, right? So here, if you bring in your data set, right, you can, and expected output, you can actually train the base model to and get the ability to talk in your language. For example, this is very relevant to some legal or financial or even medical field, but there is expected output is in a specific format, and by training these model, it will be able to get that relevant output back to your for your application. Yeah. So, and once you train this custom model would be owned by you. It is not something which is, as again said, this is not something which is shared with the LLM provider or something. So you get that advantage, and you get that security around how the data is used or not. I know Karen did mention that, for any enterprise-ready application, you probably need some guardrails. This is very relevant because, we see that a lot of customers have interest towards generative AI, but at the same time, they want, they are concerned about a lot of things around data security. They are concerned around, hallucinations and stuff. With Amazon Bedrock, it gives you a way in which you get a safeguard for your application. You can, and again, all this is configurable. So based on your requirements, you can come in and configure what content. Let's say you want filter at the input level. Like for example, you don't want specific harmful prompts being sent to the model in the first place. You can do that. You can look at if somebody's trying to do some prompt injection attack. You can have guardrail for the output. You can look into that. If the model is not providing PI information, if it's not supposed to. Let's say if you're in the RAG area, you are providing the LLM model with PI information, but you don't want that in the output. In that case, you would have to look into removing the PI information. You can even remove it so that it's not shared with the LLM model. So all these capabilities are provided as a part of Bedrock guardrails. And the wonderful part is these guardrails work across the model, right? So if you have these guardrails configured, and you're working with multiple models, and you can tweak these based on the model, but you get to use the guardrails across different large language models. Another thing is on the side when it comes to production use cases is hallucinations. The Bedrock guardrail is also able to kind of detect hallucinations, and it is able to kind of provide some groundness when it comes to getting the response out, right? So that's another advantage you will see. And the core area which we are always talking about, security. So when it comes to security, you have to understand that the your data is your differentiator, right? So these language models are out there. You can get value out of it. The most value you can get out of the generative AI applications is by leveraging your corporate data the best. But at the same time, you understand you don't want to give out that data to train these models. So none of the customer data is used to train the underlying models, right? If you do fine tuning, that's owned by you. All that data is encrypted even when it's at rest, right? So if you are storing data, we provide you all the mechanisms to encrypt that data at rest and in transit, right? We provide capability to securely transfer that data through customers VPC by using private links. So none of the data is going to go on public internet. Again, there are certain data residency requirements. So this data is also not going to leave the specific region. So if you have data residency requirements, those can also be met by deploying the Bedrock service in that specific region. So you don't have to worry about the data leaving a specific region. Right? We also support specific compliance formats like GDPR, SOC, ISO, and HIPAA eligible. The service is also HIPAA eligible. So if you are creating services which need certain compliance, there are ways in which you can use Bedrock and meet those compliance standards. I would next like to dive into the demo because all this was all about Bedrock, but I want to actually show how things work together with Couchbase vector search. Let me go on and share my screen there. Okay. Looks. Yeah. So I just got signed out because I was like, yeah. So let me sign back in on the Couchbase side, and we will go into how things look. So what I have done here is I just set up my account to have a demo cluster, but at the same time I want to show this like how I can get started. So how easy it is to get started creating a cluster as well. So I have a separate account here. And now you can actually get started with Couchbase Capella account for free. So I'm just going to activate my free tier because it's really great that Couchbase now has a free tier there. So once I activate a free tier, I get to have a cluster started. I've already started a cluster, so let me see if I can get my account activated and set a cluster here. But I can go ahead and showcase what I have configured on my demo cluster right now. So on the cluster, I have configured the travel sample. So what I've did is I have added a travel sample onto my cluster. And in that travel sample, we have a lot of information around airlines, hotels, and routes specifically which were used. I am specifically working with the hotel collection here. And let me go back to the data tools documents to show you around what's the structure of this is, right? So this one has kind of a little synthetic data as yeah. So what we have here is a data around hotel with address and other information. Just because like it's a JSON structure, we can add lot of information in the Couchbase documents here. There is a specific review section. So there are multiple reviews which are added here by customers. And as a part of this configuration, this is what how a vector embedding is I'm creating a vector embedding. So the whole way in which similarity search works is it tries to find a nearest neighbor based on the vector information. These vector embeddings are in a mathematical, and multidimensional vectors. Kiran did talk about how Couchbase specifically works on the indexing part. So I have also created an index for these vectors, right? And so I specifically leveraged, and it was very easy for me to go around and add specific fields which I needed to be part of this vector. But at the same time, Couchbase does provide you the capability to import these vectors as well. Yeah. Next one, let me check if, yeah. So I have the capability in my fresh account to create a cluster. I'll just go over creating cluster and yeah. Oh yeah. So free account, and I will just name this demo again to get started with. And yeah, so my cluster is up and it's deploying. So it was so easy to get started with getting a cluster. And once I have the cluster, I can import data set, like the sample data set, and even get started here. As a part of the connection field, the key elements which I did before I got started with the embedding part was set up a few things around connectivity. Let me show you in the already running cluster. I did two parts. One is connectivity. Okay? So in the connectivity piece, this is the connection string I'll be using for this exercise. But again, I would need to allow it to talk to. So for example, if I have a client which has to connect to this database, I have to allow the IP addresses. So in this case, I am allowing it to talk with any address, because this is just a demo. But at the same time, Couchbase does provide private connectivity. So if you're doing this in production, you can leverage private connectivity, VPC peering or private link, so that you can talk to the AWS services which are running in your account and Couchbase without traversing the internet. The second thing which is required is cluster access. So I also have set a cluster access, a specific role, a specific user with adequate bucket permissions, right? So I have read-write access here. Next, I will be going into showing how, as a part of this exercise, I believe a specific Git location has also been shared with you guys. So, so you can later on look into which notebook I'm using as well. So this is a RAG notebook exercise which is already published on GitHub. And as a part of this exercise, I have a SageMaker notebook running from where I will be running this particular Jupyter notebook. In the first part of this one, right? So any documents which are, even with Couchbase, these documents are part of Couchbase already. The sample data was already in there. But at the same time, we need those vector embeddings to be generated, right? So as a part of this, I am in the first part, I am generating these vector embeddings, and we would preferably want these vector embeddings to be stored right next to our data so that we can retrieve the relevant information from our data. So first part, I'm generating those vector embeddings, storing them back to the Couchbase, right? We also have a vector index created. So now Couchbase can search and get back those relevant documents to us. Right? The second part of it is when now you want to use a large language model in a RAG fashion, and a user asks a prompt question, those go back into uh, uh, the first part will be, of course, like kind of generating uh, the vector embedding for the question as well, trying to get similar documents from the database. So it gets only the relevant chunks. That's very important because you have to understand for all these language models, they will be kind of pricing on two factors. One is the amount of input data coming in and the amount of output data going out. So you want to only send the relevant chunks to the model, and then you get a response back. Even here, with the capability of hybrid search, you can restrict to more relevant chunks. For example, when it comes to semantic search, it's cleanly able to kind of get similar context. Like, for example, if you use price or cost, both of those are captured. But at the same time, if you have relevant filtering means, you can send those over and filter only relevant chunks so that those are only sent to the model, right? So, for example, price or cost only for year 2024. I want to now go ahead and send those to the model to get a more relevant response. So in this one, what I'm doing here is, as a first step to prerequisite, I am going to get the LangChain libraries for Couchbase and AWS installed. Next one is this is just I'm trying to print it in a way in which I will be able to show you guys better, right? So this is just a library for that. I believe I have ran that already. And I'm getting the Bedrock client started here. So once the Bedrock client is running, I can go over and get the two models. One is the large language model. I'm using the Claude 2 model here. And second is the embedding model. So I want the embedding model will be used and the part one, which will create all the vector embeddings for the data which you already have in the database. And the large language model will be used for the RAG use case where you ask question and it's going to generate a response. So let's configure both of those. Next, I have the configuration for the Couchbase cluster, which I am going to use. In this is the part where I'm actually creating those embeddings. So what I'm doing here is I wanted to share some relevant part to the large language models. So in this, I'm actually generating. I'm only sending the reviews to the large language model. So that's like I'm trying to kind of giving it a controlled data set. But at the same time, because Couchbase is in JSON format, you can send a much wider whole document as well to the large to generate the embedding. In this, but again, you have to remember that all of these embeddings also have an input window. So based on your data sets on your Couchbase side, you might be able to use the full JSON document to generate the embedding, or you might have to take a subset of it to generate the embedding. Here, I'm taking a subset because some of the documents were large, which wouldn't have fit in the input bucket for generating those embeddings, right? But I'm giving it the name of the hotel, the description, and the reviews. So there are multiple reviews, so I'm kind of concatenating them and then sending it across to have a vector a whole concise vector embedding, which might be able to search through the reviews. Next part is I'm defining Couchbase as a vector store here. So now it is able to then act. And next thing is I'm going to do a similarity search. And this query, let me run this again. So in this query, what I'm doing is I'm specifically asking, and making a search on what are the hotels with best reviews in the city with Golden Gate. So in this scenario, you see that the large language model is able to actually find out, though the city name is not included, by doing similarity search, he's able to get that this is probably the right city based on the specific key location which I have given here, right? Uh, you can also see k equal to 5. So this is like the top 5 results which I'm asking for, right? So based on the this, it will give you the top number of results back. Okay? There is also this metadata part. So whenever I have created this chunk, I have also selected metadata, and this is part of the index which we created. So we, on the Couchbase side, you remember on the search here, we have this index. This specifically maps into what would be the metadata part, which should be part of the search index. So that's where that is coming from, right? At the same time, you can also include what should be the page content, right? So this is the page content which I had created when I said I created a subset of the data which I sent to create the embedding. So this is that subset of the data. I stored it on a data string. This is already stored next to the same documents, right? So let me go back to a document and show you guys. So yeah, this one didn't have any reviews, so I didn't include any documents without reviews. Right? Let's see a document with reviews, right? So this document has multiple reviews, and you would see I have created a data string which has information about the hotel and then all the reviews as well. Right? Next one, I wanted to show around the similarity search part, or the filtering part specifically from Couchbase. So even in this one, you can add additional filtering. For example, what if certain customers might have, or there might be certain key locations in multiple cities, and you still want to probably filter on the specific keyword, San Francisco. You don't want other locations or other reviews which we're talking about, the Golden Gate or San Francisco to be included. So now you can do metadata filtering as well. So by this you get more concise, more relevant documents, which can then be shared with the large language model, right? You can also update this to kind of have a less number of responses back. And this is what you can tweak, right? Like for your business use case, you might see that you have to send a lot of information to the model, or you might have to send very few documents if it's able to get enough context from those documents. The last part here is, we have the similarity search now. We also have the key aspects around all the embeddings are generated. How do we actually use them for more RAG concepts? So this is where I've defined the context, right? That use only the following pieces of context. So this is the prompt template which I'm using. So it will be looking for what's the context which is being sent. I'm searching for top K here. right? So, and I'm just asking it, right? Like which hotels have negative reviews in San Francisco. So in this case, right, and let me run this again. So again, remember this, because these large language models are kind of generate this context, it's not the same all the time, right? So it might be different, and you have to understand that because these large language models might have some work on some temperature where they try to find try to take the context and kind of try to create the output. It might be different in certain circumstances, right? Here we see that it's trying to list which hotels have negative reviews and also giving us why they are negative, right? Like all this is synthetic data, so please don't take this for any reviews very seriously when you're booking for any hotel in San Francisco. But at the same time, I wanted to showcase how this can be used to kind of go through a lot of content and give us only the highlights of it, right? And this is going and reading through all the reviews and giving us the top, why did they feel that this hotel was bad. So it's kind of, we don't have to go and read through a lot of reviews and kind of get a very concise picture when we want to book a hotel or do anything like that. Next thing, I'm also, kind of, let me see, okay, which hotel is best for a family in San Francisco. If I run this one now, it's able to see the reviews and see if anything is mentioned for family. And then it's able to get relevant. For example, it says that, okay, kitchen is mentioned, right? A family might not be mentioned, but a kitchen is mentioned. So it's able to get that full kitchen in rooms and suites might be convenient for family. It might also get that okay, free breakfast and evening receptions is probably good for families. So it's able to drive that, the large language models are able to at times get that relevant context, and then it might be able to give that response back, right? Uh, but at the same time, the complexity of the ask, for example, if we are going to work towards very specific ask. If I'm going to this event, I'm staying here, what's the best place to look for? It might look into all the reviews and then get a response back based on the reviews people have written. So you can take really advantage of this, and it would be able to just get that response back based on that context. I will stop sharing here. I believe, Kiran, you want to kind of share some more
Yeah,
insight
sure.
helping customers.
No, I'll just conclude this session. Thanks, everyone. So there's just one slide that I want to share before we open it up for Q&A. We walked you through how to build an enterprise-grade GenAI application using the capabilities of Couchbase and Bedrock. And there are some takeaways that I want you to go one second. Can you see this? Yeah. Okay. A few key takeaways on the Couchbase side. As I showed you earlier, all you need is a single database that provides functionality around caching, vector search, and the operational data capabilities. We are JSON compliant, so you get the flexibility of JSON. In addition to that, you can create omni-channel presence here with offline, mobile, edge, and cloud support. And in addition to that, we are a multi-model database that spans various models such as time series, geolocation, key value, and so on. And we have a broad ecosystem of integrations. We have like 20 plus integrations that you can bring to bear to create your GenAI pipeline. And with that, I will leave you with a few resources that you can use to get started with your GenAI projects with AWS Bedrock and Couchbase. With that, I'll let you ask any questions to us.
Kiran, I believe there were a question around free courses or certifications. Do you know if Couchbase has that?
I think Suzanne responded to that already. So I think she
Okay.
has listed all the
Oh, yeah,
links.
she has listed those courses in the chat as well. Yeah.
And with that, if there are no questions, we can conclude this session. Thanks all for joining.